Dear viewers and subscriber, thanks again to watch our YouTube channel Max the Service. Max Service is the only YouTube channel to take care of providing videos with proper information like documentation, architecture discussions, and working with practical examples for beginners and expert to learn by watching videos on Max the Service YouTube channel and start leading in the industry.
Dear viewers, in last session we have detailed discussion on what is container and its properties, how it's self-contained, all the libraries, environment, dependencies, everything. And also we discuss its isolation, how it independent and portable. We discuss the use case, why we need container, what is the difference between traditional software development and deployment, and with container what are those changes, challenges. We have explained very well with architecture discussion and use cases. Due to containers isolated process, we don't know where does it get its files and configurations, how do you share those environments. That's where container comes, container images comes in. Actually, container image is a standardized package that includes all of the files, binary, libraries, and configurations to run a container. Here you can see in this image, we have different layers containing different kind of material. Like at layer 4, we have source code. Whatever application we are going to work with, source code would be available on layer number 4, and layer number 3 all the dependencies. Let's suppose we have developed application in Java, all source code will be available. If you can change your source code, like in Java application, if you want to change the dot class on production, on deployment, within a var or jar, you can change, go and extract all var or EA or even enterprise archive. You can extract and just replace the dot class file in source code. Okay, in traditional in methodologies, we have been doing like this. And dependencies, you can also change your dependencies at layer 3. All the applications have their dependency, like if you are going to implement with Spring application, and there is any other utility that would be available here. And here you have requirements, what the projects and application is going to develop. All the requirements are available at layer number 3, where image, when we start container, actually application start reading from this layer. Okay, and here is layer number 1, which is fourth layer, right? Actually one layer. Here is runtime. For example, if you are going to deploy your Java application on that machine, you must have Java runtime. You must install JDK to make the runtime, Java runtime, available to run that application. Even is that Linux, is Windows, whatever operating system you are going to use. And then this one is basis. Actually, this layer contains some basic commands and our management manager, application manager, which needs to be do some basic like system level dependencies and requirements are lie on the layer number, a basic layer, which is a base layer, image layer. Okay, the another good thing is, as we have layers and we can reuse this image, as I explained. What if I have this whole image available on system 1? Okay, then what? Should I have to rebuild another image, or can I use any layer from that? Yes, you can use any layer. if, Definitely, if you want to use all the layer, you can run another container with the same image. But if you see, okay, I have source code, different dependencies might be, it is 100%. If you have different implementation, you must have different dependencies as well. But you also have the requirement as per this application. Definitely your source could have different implementation, and that might have different dependencies and requirement also depend on all this implementation and dependencies, right? But guys, if you are going to again run the same image and application within a Java, right? Then you must have an you don't need to make available another runtime. This is the beauty of layering of this image. You don't need to layer this basic layer. You can utilize these two layers if you are going to uh, build and run another container. You can share this layer, these two layers. You can share runtime. Let's suppose if you have installed jdk 17 and you can run on that machine more than one application because you need runtime and that is available. And this is related to only your operating system. You can also share this layer as well. Layering is made possible by content addressable storage and union file systems. While this will be technical, here is how it works. After each layer downloaded and extracted into its own directory on the host file system, right? Like let's suppose it is on a host file system, extracted in different layers. When you run a container from an image, okay, if you run container from this image, a unified file system will be created, okay, here, from where layers are stacked on top of each other, creating new unified view. When you start container from this file system, okay, its root directory is set to location of this unified directory using chroot, okay. When the unified system is created, this one is created, in addition to the image layer, a directory is created. Another directory is created here, okay, on the same host, uh, for the running container. To run this container, this directory will be created. This allows the container to make the file system changes while allowing the original image, this original image layers to remain untouched. Okay, guys, got my point? This enables you to run multiple containers from the same underlying image. Within this image, if you run one container, you have seen one file system is created, then a container initiated from this, and to make this container fruitful be running in the future, a directory will be created from where this container can do some changes. If you go and run another container, the same scenarios will be happen, and this base image will be remain untouched. Okay, guys, after understanding layers of image, we will do some practical example how the base image exists, because whenever we build a new image, it becomes a base image, okay. From that onward, if you start committing and installing with that container and committing those changes within that container, it's called adding layers to that image. Let me show the example. Let's suppose we have a base image on Docker registry or Docker host. First of all, guys, you have to download and install desktop Docker, or at least Windows subscription for Linux, so that you can start working like this. So right in this session I am using Ubuntu console because in previous session we have been using VS Code. We also used Docker desktop as well. So right now I will be showing the changes, all the images container, whatever practical example I will be going with there. I will showing you on both on Ubuntu terminal and well as on Docker desktop. So let me start Docker desktop parallel. In the background it should be start, and let me uh, start with, okay, first command is to get the base image, the docker, okay, run. I'm naming it name like base container. Why base container? Because from the base image I'm going to create this one, base container. Ti, what does it mean? Only I mean interactive, to interact with the console, and T mean it will get you navigate to that terminal as well. Now you are on the root of this Ubuntu operating system with Mahtab Abbasi. Once I execute the command with manage ti or dash ti, it will navigate to you on the container console. So what the name of image, base image we have already on GitHub. It will look into local machine. If it is available, downloaded already, then it will start working container, base container. Otherwise, it will first download and it will run your new container with the name of base container from Ubuntu base image. So let's start and see. Yeah, unable to find image locally, so it will start downloading. And guys, it will navigate to the terminal of Ubuntu. And once we start container, as we have discussed in previous slide, that it will be created its own directory system where we will be downloading the node.js or any other library, and then after committing, it will be adding another layer to this Ubuntu base image. Now we have downloaded new image Ubuntu, and you can see from Mahatavasi we are also navigated to terminal of this container. Here we can see we can use ls, dir, whatever we have available here. So now I will first try to update in this new terminal so that everything will be available, and there might be no use of anything else regarding to running and upgrading this container, running this image. So these are the basic commands we first start. Okay, done. Now I will install apt install node.js. Now this node.js server will be downloaded on the new container directory. It will not available outside of this container, because we are in this container terminal and now it is being downloaded in this container specific to be used within this container. Okay, now I will commit this node.js to the image so that I can start working with this image Ubuntu with already installed node.js. To do this, first of all, I will check okay if node is installed, and let me try to console it. Log hello max the service. Sorry. Here you can see. Okay, we have node installed, and we can also echo whatever we have. We can print log. And now the point of understanding, once I will commit these changes, it will add another layer to previous image downloaded with the name of Ubuntu. Okay, now let me commit this docker. Sorry. Okay guys, remember that you will not be able to run docker related commands here. Remember that, because you are on terminal and you can download, install Other related to terminal. If you are on Ubuntu, then all Ubuntu related commands you can execute here. If you are on Windows, then Windows related commands you can execute here. Now I will have to uh, go to another terminal, and first I will see, okay, I have started new container. Is it running or not? Docker ps. Okay, we have running on the port 8080. You can see here 5 minutes ago we have started this one, Ubuntu, as the with the name of base container. So I'm going to commit these changes because I want this node downloaded as a layer to the Ubuntu image. To do this, so that anyone else from my team, if start running container, node will be available in this image Ubuntu. Anyone else don't need to install it again. But remember that this Ubuntu image will be the base image. You can start working this. It will not be it will not get change or anything else. Okay, so to do this, let me docker container commit message add node base container, and now I'm going to create new image. After committing these changes, I will be having node base. Now you have node base image with node installed, but Ubuntu with it is a base image. Anyone working starting work with base image Ubuntu, no one will be having node. But starting with node base, it is Ubuntu but with node layer available, node installed. Or you can also use Ubuntu, and you can also start with JDK Python instead of node, but this base image will remain same. Okay, let me show you in the example. Here you can see this base image will remain same. Okay, and you are actually you are going to change the runtime. You are adding layer. You have runtime installed like node.js, and I can use base image Ubuntu, and I can start with JDK. I will install JDK. Base image will remain same, but the rest of layers will be changed accordingly. So now to check either I can see these changes as a layer or not, I will do log docker image history of node base. Great. Here you can see. Here we added the another layer into this image node base. If you will check the history of Ubuntu, you will see we also have added here. Okay, now guys, we have seen that how we can add how we can use base image and create new image with addition of some layers. And let me check, either we can use base image docker run node base node e, as we printed with the Ubuntu. And now I'm going to try to check new created node base image either have installed node or not. Console.log hello max the service, sorry. Mhm. Yeah, Here we have again. Okay, if now we can just remove the container what we have. Let's suppose, let me check how many containers we are running now. Docker ps -a. Here you can see we must have two container, base node and base container. Okay, here is base node, sorry, node base and base container. Clear. I can remove. Okay, one thing more, guys. If your container is working and you are going to remove that one, okay, rm base container, it will ask you to stop this. If you don't want to stop and just remove with the force, you can use this one. Now you will see there is only node base. Okay, guys, same thing I can show you in the Docker desktop. But one thing about the base images, a base image is a foundation for building other images, right? You can use Ubuntu for build to start building and other images. There is no any change within Ubuntu. It is possible to use any images as a base image. You can also start with the making this base image. Okay, guys, you can share this node base and make sure that this is our node base. Whenever you start your container with any other dependency, just create another image. The command, let me show you, we have used. Here is, here you will write node base and here you will write new image name, and this node base will be always base for everyone, and another whatever you are going to add, commit another changes to that new image, it will remain changes. So in this example, we probably will not deploy this node base image as it doesn't actually do anything yet, but it is the base you can use for other builds. Okay, guys, so I can show you all of this. Here you can also see node base we have also available here, and I can also delete from here as well. These are the containers and these are the images we have downloaded Ubuntu and Nodebase. In previous session, we have worked with the Maxi Server demo with using OpenJDK. So we can also stop and download, delete here as well. And okay, guys, so this using base image is rarely used. You will never experience, but it is very important to understand how the layers of images work and how we can add layers, more layers within an image, and how we can use base image and run container from them with the rest of the addition of dependencies or runtime, whatever layer we are going to add. And in the example you can see this is read write from this container layer. As we have seen that we have committed from this layer and new layer is added with already what we have layers within the base image, are because we can make any image as a base image and start working from that. So in next video we will be working on Docker file, all the commands, all the information, instruction, whatever configuration we use in the Docker file. I will be explaining you, and please stay touch and subscribe if you have not, and also share in your circle so that other your colleagues, your friends, all also beginners, learners can get benefits, because I'm trying my best to with important things to be highlighted, and everything I want to highlight and explain you, so that if you start learning and doing practice with max the service, there will be nothing to left. So that I try my best, and also please do your comments so that I can improve myself, my videos for you if you believe. So let's connect in another video with Docker file. Please stay touch and see how Docker file work and how we can go with every step, all the modifications, all the commands, all the configuration. I will show you practically. Thank you. Bye.